There are numerous ways of solving quadratic equations. One way to solve them visually is to graph the quadratic function and find where or if it intersects the x-axis. In this video, we'll look at solutions to quadratics that involve graphing. Let's start with an example. A field goal kicker kicks the ball 40 yards from the goalpost. The motion of the ball is modeled by this function. H equals negative 16t squared plus 35t. In this function, height h in feet is a function of time in seconds. How long is the ball in the air before it hits the ground? Does the kicker make the field goal if the ball had a horizontal velocity of 20 feet per second? First, let's take the quadratic function and graph it. You can use a graphing calculator to do this. Here we see the graph of the function. Notice that the graph intersects the x-axis at two coordinates, the origin and 2.1880. This means that from the time the football is kicked to the time it hits the ground, 2.188 seconds elapse. We are told that the ball has a horizontal speed of 20 feet per second. Combining both the time and speed, we get that the ball travels a total distance of 43.76 feet. Recall that the ball is 40 yards away from the goal post, which is 120 feet. Since the football only travels around 44 feet, there's no way the field goal is made, since the ball doesn't travel far enough horizontally. Let's look at another example. The area of this rectangle is 28. Use this to determine the side lengths of the rectangle. We are given three pieces of information: the length of the rectangle, the width, and the area of the rectangle. Let's combine these using the area formula for a rectangle. Multiply the length and width and make it equal to 28, as shown here. Expanding the variable terms and subtracting 28 from both sides, we get 2x squared plus 2x minus 28 equals 0. We can simplify this further by dividing both sides of the equation by 2 to get x squared plus x minus 14 equals 0. Let's graph the left side of this equation as a function. Here is the graph of it. The parabola intersects the x-axis twice, at values negative 4.275 and 3.275. Going back to the rectangle, we see that the only solution that works is 3.275. This makes the dimensions of the rectangle roughly 4.275 by 6.55. Multiplying these values gives us an area of about 28. Let's look at a final example. Can a triangle with these dimensions have an area of 10? If not, what is the maximum value for the area, as well as the corresponding values for the base and height of the triangle? We know the area of a triangle is 1/2 the base times the height. Substituting the base and height expressions, we get this equation for the area. We need to determine if this equation can equal 10. So we end up with this quadratic equation. This is the equation in standard form. Let's take a look at the graph of this function to see if it intersects the x-axis. Here is the graph. As you can see, the parabola doesn't intersect the x-axis. So there is no solution to this quadratic equation. So this triangle cannot have an area of 10. What areas are allowable? We have to find a parabola that intersects the x-axis. If you use different values for the constant term, you'll find that the first allowable area is when the parabola intersects the point 1, 0. For a value of x equals 1, the base of the triangle is 1, the height is 3, and the area of the triangle is 1.5. This is the maximum area for this triangle.